How do I identify and debug a memory leak? Now, memory leak basically again means you're allocating memory, you're basically using your heap, you're allocating memory and you're freeing up memory. But at some point in there, you forgot to free up your memory. So how would you check that? One of the most uh, basic way of doing that is basically you keep track of the malloc or whatever, if it's like allocate, whatever you're calling. So you count the number of um, mallocs, and you count the number of frees, like how many times you have freed up that memory. That's one way to keep track of, like, if at certain point you see that you have called malloc like 20 times or 30 times and you have only freed up it 10 times, then either you should be able to tell that, oh, those 10 mallocs that I called, they are related to these instances. Like you should be able to track either using that way, which kind of is difficult unless you're only calling like a limited number of you're allocating memory a limited number of times. Um, but that's one very basic way, like that I think there was at one point it was tracked. I forgot. I think I read an article, but in like earlier on, in very early like garbage collection mechanism, that was it was internally. That's how it was tracking which memory is ready to be garbage collected or not, or at least it was tracking that, okay, how many, like it would, the garbage collector would run once in a while. It would look at all of the memories that were allocated and see which one of them have been freed, the ones which have been freed before or which are still in use. It would kind of track using this. And another way was, it would, yeah, this is reminding me of my operating system class, but it would also track that if your code is still has a reference to it. If it still has a reference to it, means that you're using it. But at a very basic level, this is how you do. Other mechanisms are more involved, but the one of the biggest one is basically var grind. It's the tool. Basically, what it does is that it's pretty sophisticated and it's a pretty good tool actually. It basically tracks each time you allocate memory and you assign it to, like, let's say you did something like you indicate pointer equals to malloc, like you cast it over whatever, and you said like 64 bytes or whatever you want to allocate, right? And this was part of a function. So over here you have a function starting fun void, and over here it ends, but you don't free up the memory, right? So it actually, it's like very intrusive in the way that every time a malloc happens, it basically sees, tries to see where it's assigned to. It's pretty smart and pretty well designed to. It is able to detect a lot of issues basically. So what it basically does is that it identifies when malloc was called, and basically, and if that pointer where it was assigned to, if that pointer still exists or not. If that's, and how can you tell if that pointer still exists or not? There are multiple ways. One of them is that whether it still exists in the stack or not. Is someone still have the handle to it or not? If no one has a handle to it, then it means that you code forgot to free up that memory. So that's one very basic example that I gave, but it has a lot more sophisticated ways of doing that. You should look it up sometime. It's a pretty good tool. Of course, it also has its limitations. Like it basically requires a lot of time. It requires that your code can run on your local machine. Um, like a lot of firmware code doesn't allow you to do that, so you have to like mock it up or do things like that. I saw some time ago that they had kind of integrated it with Google Test and like continuous integration. It was pretty interesting idea. So that then you kind of get for free with each Google Test. You kind of are also testing for this memory allocation for memory leaks in there. But that's the other way. Other than this, like there are some ways in C++ where you basically take advantage of, again, it's not a way to identify, but it's kind of a way to prevent memory leak. So the way you take advantage of that is basically that, let's say that you need to allocate a memory of 128 bytes or whatever, like 512 bytes, right? And that 512 bytes needs to go into an array, right? It has to be an array of let's call it ARY 512 bytes array, or it could be like, or it could be a glob, whatever you want to call it, right? I'm just giving a simple example, ARY 512 bytes, but you don't want it to be on the stack. So what you do in the C++ is that basically in constructor, you set up a constructor. Let me just call it constructor. And in constructor, you malloc that memory, right? Let me actually, okay. So you basically create a class, and class name, again, fun. I think this is I forgot, and I haven't used C++ in a long time. But this is, let's say this is how you create a constructor, fun. And then you basically, this is the constructor. If someone has used C++ in recently, let me know. Haven't used it, so I'm kind of blanking out the exact syntax. So over here within this, you basically call malloc, and then you have a function like local variable x, and then you allocated the space, that whatever space you want to allocate it, like you call the heap. And now what you do is that because it's C++, you now, as part of the destructor, I think its syntax is something like that. Let me Google this. Yeah, I think it is how you create a constructor and for destructor. You basically, I think you make that sign next to it. Yeah. So you make something like this, fun. And over here you call free x, right? So now what you have done is that you have basically create a special class, which as part of its constructor, it calls the malloc, and as part of its destructor, it frees up that space. Now, wherever you need to, instead of calling malloc in your code, what you do is that, let's say that you are in some other routine or in some other task, you have a function called, let's say like ingest data, right? Ingest data. It's a void ingest data. And over here, instead of calling the malloc, what you're gonna do is like you're gonna say, what was the name of that? Fun. You're gonna say something like fun f1. So as part of this, what it's gonna do is like it's gonna call within here, it's gonna call the malloc, right? Because it's part of the constructor. And when you basically go out of scope, when this function goes out of scope, you don't need to call the destructor or anything else because it's C++. it over here as part of like going out of scope, returning from this function, it would automatically call the destructor of F1. So this way you make sure that as long as your F1 is being used, it would have the, you have the memory, and then the moment you stop using the F1, you basically, it calls a destructor automatically because it becomes out of the scope. It goes out of the scope. So hopefully that makes sense.